Hi, we're going to make a video about how to do lab number 21. So I've got everything set up, and it's we'll do a mini version of it here. Okay, so here we have our little layout, and we're going to take carbonate, so CO3 2 minus, CO3 2 minus, and nitrite, NO2 minus, NO2 minus. Okay, so what we're going to do is in each well, we're going to put 0.1 molar copper nitrite. I think we're going to put about 8 drops. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Okay, if you accidentally do 9, it's no big deal. So the first thing that we're going to do is, so what's in there now is a pale blue copper nitrate solution. Okay, so what we're going to do first, in the first part of the experiment, is we're going to make an authentic sample of what happens when copper and carbonate react. And so let's go ahead and do this. So behold, I have here some sodium carbonate, 1 molar solution, and I'm going to add about 6 or so drops to the carbonate. 2, 3, 4, 5, 6. If I do 8, it's okay. All right, so in this well here, I have now added copper nitrate, and then I added sodium carbonate. So a reaction appears to have happened. I'm going to stir it around by wiggling it here. Sorry for the annoying noise. And so in the room here, I can see that a solid formed. So in the square that corresponds to that carbonate, what I would write is I would write that a precipitate formed. Okay, I would describe it, I would say maybe blue cloudy or something like that. O-U-D-Y, blue cloudy. And then we need to make a chemical formula. Because it is a precipitate, it will be neutral. So it will be copper 2 plus and carbonate 2 minus. So that makes a 1-to-1 species, and that's what it is. And let's just emphasize that it's a solid by writing S there. Okay, so that's what happens when we mix copper and carbonate. That's useful for comparing later. Now, in the next diagonal, I'm going to add sodium nitrite. Super exciting. 1, 2, 3, 4, 5, 6. Isn't that a cool green color? And you can see, or I can see perhaps a little more easily, that that is in fact a clear solution, meaning it's not cloudy. So I could write like NP or something there for no precipitate. So I could say light green or whatever color description I want to use for that. Again, that there's no precipitate is a little more obvious if you're looking at it in person. Okay, because no precipitate formed, I know it made a complex ion. So the complex ion I know has copper, and copper always forms complex ions with 4 electron groups. And each nitrite donates 1. So there's NO2 minus, like that, and there'll be 4 of them. Now, we need to add a charge to it, and the charge we can figure out as follows. Each copper has a +2, and each nitrate, and there's 4 nitrites, has a -1 charge. So 2 minus 4 is equal to -2. So that -2 is the charge that goes on the whole thing. Hopefully you can manage your space a little better than I did there. So that is what copper nitrite looks like when you mix those two things. It so happens copper nitrite forms does not form a precipitate. It so happens that copper carbonate does. So these are our authentic standards. If I had another one, perhaps I would do it down here and so forth. Okay, so we still have now to do a quotes competitive or a comparison run here in this well. We already added the copper a little bit ago. And so now what I'm going to add is I'm going to add copper carbonate, or I'm going to add carbonate ions, and I will also add nitride ions. Okay, so let's see what happens there. We'll do an example where we add it in the reverse order because we get the same result if no matter what order we added it. Okay, so here we go. 1, 2, 3, 4, 5, 6. Okay, great. So what's in here now should exactly match here, and the color looks the same, so great. All right, so we have in here copper carbonate. We have a second thing was the sodium sulfate, or not sulfate, but the sodium carbonate. So now we need to add the third thing, which is our source of nitrite ions. Okay, let's get it out. There it is. 1, 2, 3, 4, 5, 6. Okay. So I added, you saw me add the nitrite. I'm going to stir it around. Okay, so now the only thing that could be in here is it could match this, or it could match the green. This looks, it's cloudy, and it looks a whole lot more like this, like the copper carbonate, than it does the copper nitrite complex ion. It's maybe a little bit different color because there's just more liquid and it's more dilute. So for this square here with carbonate and nitrite, there's a precipitate. It's kind of blue cloudy, C-L-O-U-D-Y, and it's copper carbonate. Those are the only, so basically the only choice for this well here is this one or this one. So the off diagonal one has to match the two possible diagonals. Okay, so my claim was the order that we added, it didn't matter. And that's definitely a true statement, but let's go prove it to ourselves. And in lab, you don't have to do this. NO2 minus, CO3, 2 minus, CO3, 2 minus. So let's do this little block here. Okay, and so what we're going to do is we're going to add nitrite first. So we've got to actually get the copper back in there. So let's get the copper in here. So in lab, again, you don't have to do this order. So there we go. You don't have to do this second one. 1, 2, 3, 4, 5, 6, 7. I just did 8. You could do whatever the instructions say, which is about 3. So in this case, what I'm going to add is I'm going to add the sodium nitrite first. Remember, in this well, we added the sodium carbonate first, and it never changed colors. So here I'll add the nitrite. 1, 2, 3, 4, 5, 6. Okay, so there we've got 6 sodium nitrites in there. And it made the green color just like we expect. There's only 2 things in this well right now, only the nitrite and the original copper. So what's in there now should be this substance here. So now let's add what's in the column here, the carbonate, and see what happens, see if we get a change. So 1, 2, 3, 4, 5, 6. Okay, it's a little bit not clear what's going on, but let's stir it. This is where the stirring is so important. Stir, 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 stir. In some of these, you have to be patient and let a reaction occur. So now it's very clear to me after I stirred it, this well here looks like this well here, and it looks like this one here. So it does, and this just demonstrates that the order in which we add the compounds, the potential ligands, doesn't matter. So that means that basically the results from here are the same as the results from this. We also learned it's very important to stir. So don't forget to stir. This is our general chemistry motto. And so this one was blue cloudy, and it was copper carbonate solid. So from this result here, what we would conclude is we would conclude that copper carbonate forms stronger bonds than the bonds in copper nitrite 2- complex ion. All right, so very good. That's an example of how you're going to do lab. All right, bye.